everybody, welcome back to the next derivation on my channel, that is Schrodinger's time independent wave equation. Let me write the heading: Schrodinger's time independent wave equation. Okay, first let's know some okay, I'll just tell you. This is the symbol of wave function, and this is called as psi. This is symbol of wave function. This is equals to a e power minus I omega t minus x by v. Let me just briefly tell you what it is. This is wave. I said this is wave function. Amplitude, exponential form, complex number, angular frequency, time, position, and velocity. Okay, so let's begin. Our job is to derive Schrodinger's time independent wave equation. So first step is differentiating the above equation twice with respect to x partially. We are going to do partial differentiation twice with respect to x. So dou psi by dou x equals ae minus I omega t minus x by v, minus into minus plus, so I omega by v. Sometimes you might get confused with the differentiation and all, just go through it slowly, you understand it. Now second differentiation, I mean we do it twice, right? So dou square psi by dou x square equals ae minus I omega t minus x by v into I square omega square by v square. Now dou square psi by dou x square equals, this whole thing is basically what? This whole thing is basically psi. So just let me write that itself. Into I square. I is what? I square is what? I square is minus 1. So into minus 1, omega is 2 pi frequency. So 4 pi square nu square. 4 pi square nu square by v square. So once this is done, we also have to know that nu equals c by lambda. So 1 by lambda equals c by nu. Okay, sorry, that's what 1 by lambda equals nu by c, and this is, and here it's given nu square by c square. So nu square by c square equals to 1 by lambda square. So let's replace that. So dou square psi by dou x square equals psi into what, minus 4 pi square 1 by lambda square into psi. Same thing. Now I'll keep 1 by lambda square here and I'll bring the rest of them this side. So 1 minus 1 by 4 pi square into psi dou square psi by dou x square equals 1 by lambda square. This is an important part which you have to keep. Okay, I'll just mark it. Okay. Now next step is total energy. Total energy, which I'm representing with E, equals P square by 2m. This is another form of kinetic energy which you would have learned in 11th and 12th, plus potential energy, which I'll be denoting with P only. Now what we're going to do is, we know that lambda equals h by P. P is basically mv, right? But that we don't want now. Then P equals h by lambda. Here P square is there, so E equals h square by 2m lambda square plus v. This is basically 1 by lambda square, this part. That 1 by lambda square, I told you this is important, we will be substituting this now. I'll bring v that side, so E minus v equals h square by 2m into this, into, okay, this multiplication subtraction, and I'll do one thing, I'll put subtraction sign this side, minus 1 by 4 pi square psi into dou square psi by dou x square. So this will become 4 to the 8. So this E minus V I'll write here only because of, yeah, so I'll write here only minus h square by 8 pi square m psi dou square psi by dou x square. I've just substituted this in, I mean not substituted, I have just solved this. Okay, just solved this. Now what I'm going to do is, this part I'm going to send it up and bring this down. I'm going to keep only this in the right hand side. So that will become minus 8 pi square m psi by h square into E minus V equals dou square psi by dou x square. Now I'm going to put the whole thing that side again. So that will be dou square psi by dou x square plus 8 pi square m by h square E minus V this side equals 0. This is the final equation, and this is the entire derivation which we have done, and I hope you guys have followed it. Thank you for watching.